We're going to look at a couple of trigonometric equations. So we have the following equation on the interval between 0 and 2 pi. So negative sine squared theta plus cosine squared theta equals 1 plus sine theta. First of all, you would like to only have one kind of trig function. So I'm going to choose for us to have a sine, since we have sine in two places. All right, so we're going to work and just have sine. We're going to use the Pythagorean identity, which was mentioned earlier, but we did never do anything with it. So Pythagorean identity says sine squared theta plus cosine squared theta equals 1. So we're going to use that and see if we can substitute for cosine squared theta. So let's go ahead and manipulate it here a little bit and isolate cosine squared theta. So if we subtract the sine squared theta from both sides, that would give us cosine squared theta. And we can substitute the expression with the sine for this cosine squared theta. So we have negative sine squared theta plus 1 minus sine squared theta equals 1 plus sine of theta. All right, let's put these two together. Your coefficient is a negative 1 in each one. So we have negative 2 sine squared theta. All right, and we would also like to get a 0 on one side. So I'm going to subtract sine theta from both sides. So I will subtract it here, and I'm just putting it in the order that it would be. All right, and also I want to get this one off to get a 0. I'm trying to get a 0 on the right. So I'm going to subtract 1, and it is going to actually make this one cancel. And so now I will have a 0 on this side. And you could have gone slower and cleaned up over here before you tried to move things. Okay. I do see that I have a quadratic form here. And I have something in common. So I'm going to do a GCF. The one thing I think I would do first is I would get rid of this negative 1 that is with the 2, and then we can just factor out the sign, right? So if we want to get rid of this negative 1, we can divide on both sides by negative 1, and that's because we don't like it on the leading term, right? And that is going to give us 2 sine squared theta. This will become plus sine of theta. And 0 divided by negative 1 is 0. Now we don't have to deal with the negative. All right, for these two, we're going to do a GCF factoring. You have sine of theta in each one. So I'm going to take it out. This is GCF factoring. That's going to leave me 2 sine theta. I took one of these out. And here I took the whole thing, so remember you have to write something there. This would multiply back to give me the part above. This would be 2 sine squared theta, and this would be plus sine theta. Now you're going to use the zero product law. Either this piece is equal to 0, so sine theta equals 0, or this piece equals 0, 2 sine theta plus 1 equals 0. For this one, you will do sine inverse of 0 equals theta. And we can go ahead with that. You might remember that's going to be a quadrantal and not have to do too much there. So when is sine 0, right? Remember, sine is y. So our first end here on the unit circle would be 1, 0. This one would be 0, 1. This would be negative 1, 0. And this would be this would be 0, negative 1. Right? And so sine is your y, so we have two places. We have at pi, and we have at 0. So two answers, this one and this one. So at pi, which you want the amount you rotated there. So this one gives us pi, and this one gives us 0. So that is two answers. Now we'll work on this equation. First, isolate your trig piece. So subtract your 1. And so I have 2 sine theta equals negative 1. And then I'm going to divide by 2. And so I have sine of theta equals negative 1/2. You might remember this comes from one of our special triangles, right? And we want sine to be negative. So sine is going to be negative in this quadrant and also in this quadrant, right? And for it to be a negative 1/2, this is going to come off of a 30-degree triangle. Which is going to be pi over 6. This will be our reference angle is 30 degrees, or pi over 6. I don't have enough room in there to write it. And we have to give the final theta. This is reference angle. We want the final theta, so it's how much did the rotating arm have to go to get there, right? And since we're working in 6, this one would be 6 pi over 6, and 2 pi would be 12 pi over 6, right? So we start here and we rotate around to this one. And so this theta is going to be one additional one past 6 pi over 6. So theta is going to be 7 pi over 6. And for the other one, and we did have to rotate in the counterclockwise position direction, because it says between 0 and 2 pi. So we're not allowed to rotate negative there. To get to the other one, this arm, it is 1/6 less than this one. So that is going to be 11 pi over 6. So we have 4 answers. We have pi, 0, 7 pi over 6, and 11 pi over 6. For this example, you might recognize that this is also quadratic form. So we have another equation, quadratic form. I'm going to let sine of theta be x. So x squared is going to be sine squared of theta. Right, so I am going to substitute here. So I have 2x squared minus 9x plus 7 equals 0. Let's see about factoring this. So this is a trinomial that does not have a leading coefficient of 1. There are a couple of techniques that you might have seen. One is just a trial and error. So I'm going to take a second and review those. The other one is to change the problem and do it, split the middle term and do it like a grouping. So I'll show you both, and then I'm going to erase that and continue. So if I wanted to factor that, let's do it on the side. So 2x squared minus 9x plus 7. You could go with trial and error, and it says do like signs. Your plus at the end says like signs, whatever this one is. So both minus. You're multiplying to get 2x squared, so we're going to do 2x and an x. Over here, you're multiplying to get 7. Your choices are 1 and 7 or 7 and 1. If you try 1 and 7, remember you have to check these, right? On the outside, you're doing 2 pieces of foil. Outside, you get minus 14x, inside minus 1x. That one's not going to work. So let's switch and do 7 and 1. And so outside we get minus 2x, inside we get minus 7x. That gives a minus 9x. So this is going to work. And then you set each one equal to 0 and solve. So I'm going to, and I don't need the parentheses when I do that. So 2x minus 7 equals 0. X minus 1 equals 0. Add your 7 and divide by 2. So add your 7. So 2x equals 7. Divide by 2. So I have x equals 7 halves. Over here, add your 1. And I get x equals 1. Now, remember in a substitution problem, you have to substitute back. So I need to replace the x with sine of theta. And here, sine of theta equals 1. And so now we need to solve these two for sine of theta. So let's do sine inverse of 7 halves, that's not one I recognize, equals theta. And we'll use our calculator for some help. Right, and let me just check my mode. I'm in radian mode, so I'm going to leave it in radian mode. All right, so I'll do second quit. And I'm going to do sine inverse. So you're going to do second sine, which does sine inverse of 7 divided by 2. Close, enter. And it says we're getting a domain error. So you might remember the domain for sine inverse is between -1 and 1. Right. 7 halves is 3.5. That is bigger, so it is outside your domain. So this one does not give us a solution. Right. This one, sine of theta equals 1. Well, this is a quadrantal. Let's see when the sine of theta is 1. And we could probably also do it on the calculator. We'll check. So sine of theta equals 1. Right here, we've got 1, 0. So it's not that one. This one is 0, 1. This one is negative 1, 0. And this one is 0, negative 1. So we want this one, and that is this point here, because sine is your y. Sorry, sine is your y. And so to get to that point, this is going to be pi over 2. And since we had to throw away the first answer, this is our only answer. All right, a couple of things I said I would go back to here. If I check this one on the calculator, if you're looking for an angle, you might rather be in degree mode so that you could recognize the angle. So I'm going to switch my mode to degree. Enter. Second quit. And I'm going to do sine inverse, which I didn't even write it. So sine inverse of 1, and that should be theta. So if I go on here, I am on, so do second sine of 1, and it should give us 90 degrees, all right, which gives our rotating arm your final theta, right? So it could be on the calculator. The other thing I said I would go back to is just this factoring trick. This one was trial and error. The other way that I mentioned, so our problem is good. The other way I mentioned was to split the middle. So I'm going to just do a new page and remind you about factoring if you have trouble with these trinomials. So 2x squared minus 9x plus 7 equals 0. All right, so for this trinomial, and we don't even need the equation part here. If you want to factor this, one way is to keep your middle term, keep your first term, keep your last term, and we're going to split the middle and make 2 terms, and then we can do it by grouping. But we have to choose how to make this middle term. You're going to do 2 conditions. You're going to multiply your a times c. A times c, 2 times 7, is 14. So they're going to multiply to give 14, and they're going to combine to give your middle number. So we want things that multiply to give 14 and combine to give a 9. So 2 and 7 is going to work. 2 and 7 multiply to give 14, and they combine to give 9. If this last sign is plus, it says they're going to add. So they're going to add to give us a negative 9. So these are going to be negative 2 and negative 7. All right, so we're going to split the 9x, negative 9x, into these 2 pieces. So minus 2, each one of them will get an x, and minus 7x. So we've changed the problem. It is equivalent to that problem. We're now going to do it by grouping. And so in the first group, we'll take out a 2x, and that leaves x minus 1. In the second group, we'll take out a negative 7, and that leaves x. We took a negative out, so that's going to leave a negative 1. And when you factor this way, you want these to match a common binomial. So we end up with x minus 1 times 2x minus 7. Your order there doesn't matter. The whole parentheses can be switched. And that gives us the same factoring that we had earlier. Just going to go back on here. So I have x minus 1 and 2x minus 7. Here was 2x minus 7, x minus 1. Same thing. So you could have used the factor by grouping, change this to 4 terms and factor by grouping if you prefer that to trial and error, right? Following that, once it's factored, I would still do it the same way. I like a substitution here, letting x be the sine of theta. You can recognize that looks like a quadratic. You got something squared, you got something to the first power, and then a constant. And so that is your setup to do a substitution. Just remember, when you do that, you have to substitute back at the end. You don't want the answer for x. You want the answer for sine of theta.